All right. Welcome everyone to the Carpenter Working Group for Thursday, Jan 15, 2026. Um, for project updates, we we had released v1.8.1 in Kubernetes 6 Carpenter, which has been retracted because there was a regression. Um, and now we've released v1.8.2 for 6 Carpenter, which has that change reverted. And we also made 1.8.5 release for AWS provider, which now references the latest upstream release.
So yeah, I think we've added warnings to all impacted releases, as well as the retraction for the actual Go mod. So if you're on the latest release, though, the latest release now does not have that regression.
Can you
So
talk about the regression, like something brief about it?
yeah, Jagisha, if you wanted to link to the issue, I could talk about it.
Yeah.
So it is a bit of a specific configuration. Basically, it had to do with a change that was meant to fix an issue with topology spread constraints and node affinity policy honor. So the exact root cause gets a little bit into the weeds about how topology spread constraints are handled in Carpenter. But basically, what it came down to was we're tracking the set of requirements for all possible instance types. That way, we can determine which domains a pod can possibly schedule to. And uh, the issue was some special handling around the node pool and node class labels because they aren't injected into the core instance types. They're injected into node claim templates when they're created. What this basically ended up resulting in was if you had a topology spread constraint on a pod which had a node selector on either a node pool or a node class, we would fail to satisfy it when scaling out from zero. So there's a pretty detailed root cause description at the bottom of this issue that's linked out in all of the warnings as well. So I'm of course happy to answer any questions about that, but that's the TLDR.
Got it, thanks. I'll read through that.
All right. Moving over to the community questions. I see, Garvin, you have one.
Oh, yeah. After PR, I just want to say I screwed up and I had to close the original PR. I was trying to get the AI to get the tests moved to Ginkgo, but it completely screwed the history. So I actually had to make a new one. I called the original PR and this one. It should be exactly the same, but migrated to Ginkgo for testing. Um, so sorry for the confusion because yeah, I made a mess. But other than that, I don't think there's much else. Hopefully there's not too much more, and we can get it merged soon.
I just left what should hopefully be the last review comment on it.
Okay, then
So
okay. Thanks.
All right. Moving over. Kevin, if you are on the call, do you want to talk about this?
Yeah, so this is my first Carpenter contribution, but I'd appreciate any advice or feedback on it. Basically, what we've been running to is seeing weird behavior with stateful sets and topology spread constraints where like the volumes zone requirements um, confuse the topology spread constraints when they're calculated, and as a result, we just see like a pending pod not being and Carpenter won't provision like a new node claim for it. So I think the way it's done now is like the volumes zone requirements injected into the pod as like a node affinity, but as a result, it like clouds the topology spread constraint pod counting and like the min domains checks. So I tried to fix in this PR and I would appreciate any like general feedback.
Yeah, I saw the issue that you actually created. I was able to reproduce it, and yeah, I'm gonna try and take a look at your PR.
Okay, thank you so much.
Yeah.
Oh, sorry. I
Aaron?
was gonna say, Max, you should go first because I don't want to take up too much time, so I can come last again.
Okay. Um,
Thanks. Yeah, so I just wanted to talk about this PR. So I know that I've talked about limits a lot for node limits. But I've opened a issue previously where I guess the node limits work differently from what I expected, and it does work how it's intended to, but I don't necessarily think that, or it doesn't fit my use case. But basically, when Karpenter tries to schedule a pod on a new node, and when it does like the calculations for um, scheduling a pod on a node claim or a in-flight node claim, like it doesn't reduce the amount of resources during that calculation. And I think for nodes, it would make sense for it to um, know that how many nodes is going to be taken up from one pod, or I guess one schedule of a node, if that makes sense. So I guess the PR is just to be able to add a capacity to node claims, I think. And then every time you are scheduling, then Karpenter knows that it will take a capacity of one node. And so before you get over the node limit, like Karpenter will stop you from creating more nodes rather than when you're already over the node limit, it'll stop you. But let's say you're at like 6 nodes and your limit is 6, it's not gonna create more than you think, or it's not going to create more than the limit, if that makes sense.
Yeah, so just to confirm, I think this is the case based on our previous discussions. This wouldn't be making it such that it's a hard limit, so like drift or consolidation couldn't burst over, but just that we won't provision over during during provisioning, right?
Yeah.
So same behavior as like CPU limits, memory limits, pretty much everything else today.
Um, it well, currently how the node limits work is it works exactly like the CPU and the memory, I think. But what I'm changing here is that I guess how do I explain this? I guess like in the code, there's that loop where you parallelize until the amount of node claims are um, created or something. But in that calculation, there's it checks the node it checks the limits and checks how many resources are left. But for nodes, I think it doesn't work, or I think it should work differently from the other resources in that before you create a node claim, I think, sorry, I'm getting confused. It's been a while.
Yeah, I think we'll have to take a look. The way that you've described the way that you think node limits should work sounds to me like the way CPU limits, memory limits, any other resources are also supposed to work. So if there's an inconsistency there, I'd definitely like us to be able to dive in and see why. Because we shouldn't over provision our limits during provisioning, basically.
Right. Well, I have a video on like the issue, which sort of shows what I'm talking about. Um, where I remember what was on there. I had a limit of 2, and then I had 2 nodes, and then I could still provision more than the limit of 2 to like 5. But then if I tried to provision more than that, then that's when it would stop. So that's why it worked differently from what I expected. And I don't know if that's the case for other like resources like CPU or memory, but judging from the comments, apparently it's supposed to work like that.
Well, so with nodes up till now, it has been like node limits have been undefined. I think what we've discussed in the past is that they may work, but the behavior is undefined. We would need to strictly define it to make any guarantees, which I think we're working to do with this. But the way that CPU limits, memory limits, etc., are supposed to work is that when we should not exceed the limits when creating new node claims. It shouldn't matter if the nodes have joined the cluster or not yet. So like I saw that Jeremy had went and clarified his comments. It does sound like that is not intended behavior. And I think Jiggy should ask to create a separate issue specifically talking about existing limits so that we can root cause and identify what the potential issue there is.
If I remember correctly, isn't the issue that if you are actively deleting something, the deleted nodes don't count toward your limit? So that's how you could go above and burst above on provisioning.
Yeah, I think in this case, though, there wasn't anything deleting either.
Oh, interesting.
So at least I didn't see that in the description. Because yeah,
No,
there are
I don't
definitely
think
cases
so.
where you can burst above, but it should still be scoped.
Yeah, so I guess what is the next steps for this?
I think one of us will have to take a look at your PR. I think aligning the behavior of nodes with other resources isn't very contentious. And I think from previous discussions, we've kind of aligned on that. I don't know if it would need a feature gate. I think up until now, the behavior of nodes has been undefined. So
Okay.
we should just be able to go ahead and define it. I don't know if anyone disagrees. But then, yeah, I think we'll just want to make sure that the behavior is aligned as so long as like the behavior that CPU memory, all other resources have is or does match what you believe nodes should have, which based on this discussion, I think it does.
Gotcha. Okay. That makes sense to me. Then thanks. I will remove the flag if in the next round of reviews and such.
Yeah. I think the only reason we may want to consider a flag is if the behavior is divergent. But I think if we're talking about divergent behavior, it will probably take a little bit more evaluation of what that behavior should be. But if we're just talking about aligning behavior, it's a different story.
Gotcha. Okay. Thanks.
Right. Moving over. Garvin, do you want to talk about
Sure.
the issues that you have linked?
It's two small issues. First one is controller runtime now has a feature that allows your followers to have a warm up even when it's not leader. So at high level, when you become leader, you start filling up your informer cache with like pods or nodes or whatever. There's a feature now on the control runtime that even if you're not leader, you can fill that information up. You won't actually start processing and building the subsequent caches like Karpenter does, but you just have the pods, the nodes, daemon set, whatever ready, so that when the leadership fails over, you start with not a blank slate and you don't have to do the informer stuff. So this is simply adding this option that if you're enable leader election, you can also turn on warm up. for a faster failover. The change is relatively small, and I don't know what kind of testing we want to do. I tested it briefly ourselves with the failover, but yeah, th this change mostly rely on the upstream control runtime library enabling this feature. So I assume it works fine, and I didn't see any weirdness. Like it's still building the cache and runs all the appropriate things from what I can tell after it fails over. But yeah.
I guess the main thing I'd be wondering is there any reason not to enable this? Should we just enable it by default?
I
Or-
think it makes sense. I'm just scared that there's something funky, and I haven't thoroughly tested. I don't know if we should bake a little bit with the community, testing it out before we're like, okay, let's default this on. But yeah, I think eventually, I think it makes sense as a default. I just don't know right off the bat, should we make a default, if that makes sense? Just in case, just to be cautious.
I think that the main thing to be or in a separate project, I've enabled controller remote. The main thing to be concerned with is if there's any logic that like doesn't release things cleanly, or like basically you could be left with like a memory leak if you're not if the followers aren't doing cleanup correctly, or I don't know, there's just some edge cases, so you just might want to test it out.
Okay. I guess I don't usually mess with the informer um transformation, especially cleanup. So I don't have anything that would possibly leak, hopefully. But it doesn't do any subsequent like it doesn't go like you have a pod now. Okay, now I have to do the next step of building the cache of whatever to hydrate that. It doesn't do the next step. It simply hydrates the informer cache from what I can tell.
Yeah, the other thing I'd wonder, and this is something I think we definitely want to verify before going forward with a feature like this, is there are a few places we rely on like the predicate of this is the
Right.
first time this object has been added to an informer cache. Does controller runtime still, like when the controller first starts up, even if let's say in the background the informer cache has been updated a bunch of times,
Right.
will it still
Yeah.
pass all of those objects through for that predicate as if they were first created, if that
Yeah,
makes sense?
yeah, that makes sense. If you can send me, if you remember where it is, can you send me? I can take a look and test it out because that's exactly the supplement. I'm not 100% sure.
Sure, the place that I'm thinking of is in the AWS provider, but I can send
Okay.
you that link.
Okay, thanks. I think that's the first thing. It's still experimenting. But then the second thing is, I don't know if anyone else seen this where on a creation of a new node claim, it complains about it's missing labels for cost tracking, but the whole node claim creation is out of my hands, I thought. So I wasn't sure why this shows up when I don't fully control the node claim. I don't know if there's some coordination issue with the cost tracking within the no claim controller or something, but something seems off because I didn't, this is not something I control, I thought.
So just to clarify and sanity check, I take it you hit this on a custom build?
Uh, we built off of, I forgot, 1.8.2 from AWS provider.
Okay, because I didn't think the cost tracking code was in main yet. Or
Oh,
not in main. It is in main. I didn't think it was in a release yet.
I can double check. I
Yeah.
thought I pulled from 1.8.2, but I could definitely might have messed up and pulled from main. So I can
Okay.
double.
Yeah. No, I would agree. I think this is a miss in the original PR to add cost tracking. These labels can only assume to be on a node claim once the node claim has been launched, like
Yeah,
marked as launched.
that's what I was thinking too, yeah.
So there are a couple of other edge cases with different node claim states that it looks like the cost tracker had missed. So I think temporarily we're at least reverting that PR from main. But like I said, as far as I know, it should not be in a release.
Okay. Let me double check that. If it's not, then yeah, that's not an issue, but I think we can fix it. But yeah.
Well, it's an issue. It would have been
Yeah,
an
yeah,
issue as soon as it was released, but
yeah.
I just want to make sure it didn't make its way into a patch release somehow.
Yeah, for sure. Cool. Yeah, that was the only thing for me. Thanks.
Right. Moving over. I think Max, you also added another issue.
Oh no, that's just
Okay.
the underlying issue.
Oh, okay,
So
gotcha.
yeah.
Okay. Cameron, do you want to talk about this one?
Yeah, sure. All right. So the motivation here, I want to add some Prometheus metrics for the disruption decisions. There already is a metric here. The Carpenter voluntary disruption decisions total. That's an existing metric that's already in the current release. The problem is that metric doesn't have a dimension for the node pool involved. So we want to be able to do math on how many nodes could still be disrupted in a node pool based on the budget. And you could do math if you had this metric, but you can't because you don't have the node pool dimension. There is another metric that you can use for the other half of the math. The Carpenter node pool allowed disruptions tells you like if you have a node pool of the size of 100 nodes and you have 10% disruption budget, that metric will emit 10 and say that that node pool could theoretically have 10 nodes disrupted. But it doesn't tell you how many are disrupted. So you need the voluntary disruptions decisions metric, and you need it to have the node pool tag on it. This basically adds a new metric that has the correct cardinality for that math to work. We have this deployed in our Carpenter and it works great.
Okay, so it looks like Derek has already been taking a look at your PR. So
He reviewed it, but I'm not sure he understood it based on his review because it's a little confusing. There is an existing metric. We can't use it. It doesn't have a node pool dimension, and it can't be added to it either because these decisions that happen could span node pools. So there's not a way to say that this decision was for one node pool when it was for three.
No, that makes sense. I mean, Derek's out for a little bit anyway, so I can probably go ahead and take a look at this as well.
Cool.
okay, thanks. Moving over, Isaac, do you want to talk about this one?
Hey, yeah. Yeah, so this one adds the ability to configure the ENI contract settings on a node class. Yeah, it's an API layer change, but besides that, it's just implementing the AWS APIs to configure the EC2 instance with whatever you have configured. Yeah.
Not too familiar with this setting. Is this something you can configure via like, I guess I don't know if you're using the AWS VPC CNI, but is this something you would need to configure on both to configure primary and secondary ENIs, or is it something you can get away with just on Carpenter?
Uh, it's separate from the VPC CNI. You just need to configure it on the EC2 instance itself. So like when you're spinning up an EC2 instance, regardless of whether it's Kubernetes or not, you can configure the connection tracking settings. So mostly this relates to like security group contract, different from Linux contract, but by default on I think everything before Nitro v6 or maybe v5, the default was 5 days. And if you're doing things like running networking stuff, you would typically want to reduce that to something that matches whatever might be running in front of it. So like any of the ELBs or global accelerator or whatever else. Typically between I think it's 350 seconds or 330 seconds. And this just allows the ability to configure that. Initially, I only exposed the TCP idle connection timeout because that's really the thing that I wanted in my environment. And I believe, I forget who else reviewed this, but the suggestion was to just might as well add all of them. I think is what the last time I joined one of these we talked about. And so yeah, they're all in here now. Yeah, I was just hoping to get some eyes on this.
Okay. Yeah, I think this sounds pretty reasonable. I mean, this is just basically forwarding some fields that would be available on a launch template into the node class, right?
Exactly.
So yeah, I see it looks like Emmanuel reviewed this quite a while back and it just needs to get a new set of eyes on it. Fell off of radar. So yeah, I think we can definitely get a review going there.
Great.
All right. I don't see anything else in the community questions, unless someone had something.
No questions, but I joined late. Maybe do the RFCs after, but I did add those two
Oh.
RFCs if
Okay.
we can go through those at some point.
Yeah.
Sure. Yeah. So yeah, this one is looking to add a consolidation price improvement factor. I think I joined in October and we talked about this a little bit, and then I added some of the data points that we had, and then I was also talking with what's his name? James Thompson, who I think might have an internal RFC for any of the Amazon folks here. But yeah, just hoping to get some movement on this. It sounds like there was a desire to drive this forward, but this one has also just been kind of sitting. I was hoping we could maybe discuss it here. The main goal is to avoid constant node cycling for like small percentages of savings and behave somewhat like how if you're using cluster autoscaler, you can set a utilization threshold such that it won't reclaim the node unless it's below a certain limit. Within Karpenter, that optimizes around cost. The idea here is to instead set a price improvement factor. So only consolidate this node if you can save at least 20% as an example. And yeah, the driver here is that regardless of regardless of how much money you can save, there is usually some other sense of cost that you will incur by shifting pods throughout the cluster. There's other ways to control that, but one great global control or not or node pool level control would be to set a threshold that would drive whether or not you reclaim a node. Because for a lot of users, like I know there's a related GitHub issue here that had a lot of discussion around it too, and I think it's a desired feature, but basically, I would rather not reclaim a node if I'm only saving like a penny or some small amount of savings. I'd rather just let those workloads continue running, especially if you're in a cluster that has a lot of pod churn or things scale up and scale down throughout the day. Sorry, I'm rambling a bit. Yeah, that's about it. Has anyone here already read through this, or anyone else want to plus one this or talk about it?
It's been a while since I've read through this RFC, so I don't remember all of the concrete details, and I think you may have updated it since we had last discussed it. So I can't go too much into specifics here. I think, and this is definitely a space that we're looking to make movement on. So, and it sounded like you had already started or had some conversations with James, who's been looking into this on our side at AWS at least a fair bit. Yeah, I can't speak concretely to the RFC at the moment just because I haven't read it recently. I will definitely have to give it a reread though.
let me take a look too, because I think generally I agree with what you're saying. I just need to take a look at the RC, yeah.
Sure. And I think James might have a he shared it with me, but I don't know if I feel comfortable sharing it with everybody else. But I know he had a different write up as well that uh I guess I need to chat with him to figure out if I should incorporate all that into this, but just calling it out in case you want to reach out to him. But basically, I would just like to see some resolution to this issue. I think it's been open for at least a couple of years. It's something that we've built a custom controller around to try to deal with a little bit, but it's just an annoying issue to deal with constant node thrash. So is there anything else that I can help do to like drive this along, or like is there someone that could maybe take on like reviewing this and like actually getting some movement on it? It's just been a long drag, and I'd really like to see something happen here.
I think I'll reach out to James because I've been talking to him a little bit about this as well and see what we wanted to do in terms of like incorporating some of the stuff he's worked on into this, or just kind of like merging the two so we're not reviewing two separate things. And then I think he's largely driving the effort forward on like getting this through and getting like an RFC approved. But yeah, this is something we are looking to move on. And yeah, he's actively involved in working on that. And I think once we have consensus on like how this gets merged and what like the final artifact we're reviewing is, yeah, we can definitely dedicate reviewers to this and getting it merged. So I'll reach out to him to clear up any of that.
Okay, I appreciate it.
All right. I think you also had another one, right, Isaac?
Yeah. So in a similar light of avoiding disruptions, the theme of this is that do not disrupt is basically a one-way lever to block disruption, but there's not really a way to say to like basically remove that and say, oh, I can be interrupted at this point in time, there's just not enough controls around it. And there's another GitHub issue. I think it's like, I forget what it's called, or I'll find the issue number and I'll link it under this. But yeah, it should be in the description. The mega,
Yeah, the pod disruption budget, but different mega issue.
yeah, that's there's another one somewhere that I'll link here, but it's like a mega pod disruption control or something. But in any case, the goal of this is to add the ability to define a cron schedule of when your pod either is or is not disruptible. So just like adds another annotation which Karpenter can then consider. And if it is within that window, or if we decide to go the opposite, it would be outside of that window. Karpenter would be able to disrupt it.
I linked it on Zoom chat, I believe. The mega issue.
Thank you. And the main risk that exists already in Karpenter is if you're using a workload that has do not disrupt on it. Let's say you do a deployment and you roll out those pods. Let's say you have 3 pods, and those 3 pods land on 3 separate nodes. All those nodes happen to be spun up at the same time. If all those nodes reach their expiration at the same time, Karpenter isn't gonna respect their PDBs, and so you're at risk then of violating those and causing an outage or just causing production issues as a result of trying to use the thing that says do not disrupt and protect your pod, so to speak. And yeah, this is just a bit of a risky situation now, and there's like some other edge cases with it too. But yeah, the driver here is to add more ability to configure that behavior. And yeah, we talked about it in this GitHub issue of like potentially adding this in upstream into the pod disruption budget spec. I think some of this I agree with. Some of this I'm not sure that it makes sense. Um, but yeah, this is another one that I'd really like to maybe get some movement on, or maybe talk about openly here if anyone's interested.
You mentioned a use case of the expiration. Like, is that the only use case that you've seen? Like, I thought generally pods have some. If a pod is created newish, it shouldn't be killed. I thought there's some time, like 5 minutes or something, except for expiration. Like for everything else, there's some sort of timer, I believe, before the node can be killed. Um, do you notice that, or that's not true?
Well, or so or yeah, you're right, but that would be for like when a new pod comes up. I guess what I'm talking about is when you're running on a node that has, like, if your node pool has expiration set up,
Yeah, yeah, yeah.
and even if you're using a grace period, this would still
Yeah.
apply. So like the logic is Carpenter lets the node live until it reaches its expiration time. And then any of the pods that are still running with do not disrupt, they'll be allowed to continue running until the grace period
Right, right.
is met. And at that point, those pods are forcefully interrupted, and it does not respect PDBs anymore. And so, like, that's a situation that
I
is actively like causing issues. And one way to, like, I'm just running a custom controller to deal with that now. But then the other use case is basically um, I don't necessarily want to block disruptions all the time. Let's say I just want to block it during business hours for a particular workload, or I'm sure someone else can come up with other use cases. I listed a few in the RFC, but basically just the idea of uh, only needing to block disruption during certain time periods.
I guess I guess for the first case specifically, I'm wondering if, like, in theory, it's not really Carpenter. I guess it's script schedule, but I'm wondering if it's possible to avoid nodes that we know are gonna expire, let's say in 10 minutes, and you can specify that in some way so that like any new pods would never land on a node that we know is gonna die in 10 minutes because expiration is gonna come in that time. And maybe it's like a container or something, but that way you more gracefully churn expiration, the specific this expiration, like churn expiration nodes without, knowing ahead of time, you already know that this node's gonna go away. We really don't want pods lying there, and maybe we should be possibly tainting nodes that are about to expire that way. No new pods land on there, and we'll let the node naturally drain everything else, and your new pods will land somewhere else. Like, would that, for that specific situation, does that make sense rather than dealing with pod disruptions control or something like that?
It
That,
it makes sense, but
sorry, go
I don't
ahead.
think it would work. Or sorry, go ahead, Jeremy.
Well, so I was gonna say that's exactly what we're doing at Salesforce actually. So we have an abstraction layer. We call them compute groups, and that's on top of node pools for Carpenter or GKE compute group profiles. Anyway, compute groups create a compute group instance, which is just our thin wrapper around Carpenter node pool. Those instances are immutable. So each one of those has a specific taint. So pods go onto whatever the Carpenter node pool. They have a specific taint. As soon as we upgrade like an Omni or whatever in our compute group, a new instance gets created because the instances are immutable with a new taint, and that creates a new Carpenter layer. So we can ensure that we have a mutating webhook too to add the selectors and tolerations. All the new pods always go to new nodes after we've triggered it. So we don't have to push anything over. And for workloads, we don't really necessarily understand the best way of disrupting them, right? There's all these complexities. Some people like it, so it's just like, hey, well, if there's a new Omni and we got to reschedule everything, we just want you to kill all of our pods at once and switch them all over, right? Like a Spark job or something. They would much prefer to just stop everything, move it over, continue. So rather than use, node by node, we just create a CR, say, hey, there's a disruption ready to go. They can handle that with their whatever logic they want, handle that disruption request. and then they can restart their pods. Their pods automatically go to the new patched nodes. So that's how we handle it. So we have a similar issue with our workloads.
Or I just want to clarify something. So yeah, for new nodes, like as a node approaches expiration, I believe it gets tainted once it hits expiration and it's in the like grace period phase.
Yeah.
But even if you're doing that manually, nothing is stopping Karpenter. Like let's say that a user doesn't let's say like if like they're just not good stewards of their service or whatever, there's nothing that stops Karpenter from forcefully disrupting that node once it reaches expiration plus the grace period. And so like that's the situation that I'd like to protect from. But also offering a knob to users to actually control that disruption, the second case I gave. But we can focus on the first one of like even if you could control what nodes specifically you're like you'd basically be writing a custom scheduler to make sure that all pods from a given replica set never go to 3 nodes that have the same expiration time. Like, yes, you could do that, but why not just have a better control over that disruption logic?
Yeah, it's tricky, right? So we also have that concept, guaranteed pod lifespan. So a pod can say, hey, I want to exist for a minimum of this time. So then it shouldn't go onto a node that can be expired before then. Um, and yeah, um, it really goes into, yeah, you have to have your scheduler handle it or whatever, mutating webhooks to do all the logic.
Got it. Okay. I think from that, I understand like 2 scenarios, right? Like one is pods landing on nodes that are about to expire, causing it to like just be disrupted within like some time of its lifespan because its expiration is relatively forceful. And the second scenario is like, oh, I land 3 pods and 3 nodes are like came up at the same time, so they expire at the same time. So all 3 goes down at the same time, right? And we don't really want that. Kind of makes it like in the scenarios kind of described specifically to around expiration and it disrupting like pods availability. I think I don't know about the second case off the top of my head, but like I think it makes sense. I guess the reason I'm saying like I don't want to touch pod disruption budget because that seems a lot of work. That I have no foreseeable timeline that we'll get something. Whereas I guess something that can be handled from Carpenter that makes sense in the Carpenter world is easier to get done, I guess, in a way. So like I'm just trying to figure out like if Carpenter just taints notes with unschedulable 10 minutes before it kills, or some time that you can specify, that avoids situation one where any notes that's about to expire will get killed. I mean, will get blocked from scheduling. So you don't land case one. But case two is more complicated and it's
So sorry, I just want to clarify the case one you would kind of already get. This is specifically for workloads using do not disrupt. Carpenter does not it when a node expires, it will disrupt those pods in a non-graceful way. If you're using do not disrupt, there is no control over
right,
them.
because it's forceful, yeah. Okay.
So like that is the main thing that I was trying to resolve. But yeah, like I agree. Like adding it to PDBs is best case probably 2 years before it lands any usable API.
Yeah.
But what I was proposing here was adding 2 more annotations to Carpenter, and then Carpenter is just handling it. So like you don't have to worry about tainting nodes or really interacting with nodes in any special way. It already has a clock object that gets passed in. It's literally just reading that value, and then if it is within or without that window, it either allows or disallows the consolidation or not disruption event to proceed.
I think the original reason why expiration is hard is because there are operators like we do where like we don't really own the pods. So even if you say do not disrupt, the application owner are not allowed to breach the lifetime of our nodes because we break a compliance. That's why expiration is forceful from what I've seen previously. Yeah, go
Well, I
ahead.
think correct me if I'm wrong, but the only reason expiration is an issue for you is right now you have these pods that can only be disrupted at certain times, but you don't have the granularity to say when. So you have to use do not disrupt, which is what leads the pods to staying on non-disruptible nodes until they are expired. Theoretically, with this proposal, you would be able to recycle those pods before their expiration, and you wouldn't run into this issue in the first place.
Yes.
Ah, okay. That makes sense.
Yeah. I guess the one question I would have on the like budget side is rather than duplicating this layer from the node pool to the pod, is there a reason you don't want to just use node pools for these time constrained pods and restrict them to those node pools?
Uh, Probably goes back to cost. Like if I can, like if I don't want to manage 100 different node pool because different users might have different um, disruption desires. So then we would have to make a node pool for every single potentially like window. So that's why that's just not very, at least in my case, very feasible. So if I could use the same node pool and then basically expose that configuration option to the user rather than us as the operator needing to manage it, that would be much more preferable.
Okay, so would it basically the reason comes down to by splitting between a bunch of node pools, you would suffer like from bin packing, like lower cluster utilization, or maybe you just need more nodes. You can't pack into as large of nodes because they're spread across these different node pools.
Or yeah, but both that plus the management overhead. Like it's no longer user defined. They then have to come to our team and say, "Hey, we want a node pool that allows disruption between these times." Whereas if they had a configuration option available to themselves, we're not in their way at all.
Yeah, you would probably need to build a layer of abstraction if you wanted to make that surfaceable to a customer or to an end user.
Yeah.
Yeah, the one interesting problem that we definitely want to think about is because you kind of have this with PDBs today as well, but so if you just have one pod with one disruption budget on the node, it's great. Like you know that there's some amount of time you'll be able to disrupt, there's some amount of time you won't. As soon as you start layering a bunch of different pods with different disruption budgets, potentially you end up in a state where you're back to having do not disrupt. Maybe that ends up being fine in practice. Um, but it is an interesting problem to think about of like, okay, how do we avoid layering these pods such that the node is no longer disruptible?
Um, I think Karpenter already does a good job of sort of handling that, right? Because different workloads have their own PDBs, just like you said. Um, Karpenter can already figure out all the PDBs and it can disrupt workloads individually. So when a node reaches expiration, it can disrupt the ones that have like available budget. And then, at least in my case, we configure the grace period long enough such that those workloads will have enough time to basically move off and gracefully shift to new nodes. Um, so
Yeah, I guess. Oh, gone.
no, but yeah, I was just yeah, I'm not. I don't know what the yeah. Please expand.
The case I was more so thinking about is preventing consolidation. Like there are cases where that have been reported where you have a bunch of different pods on a node, and at any given point of time, like all of these PDBs, none of them are like permanently blocked. They're going in and out of being blocked as like pods turn on the cluster. But for the node, there is no single point in time when all of the PDBs are unblocked. So there's never a chance for us to actually begin a disruption decision. Maybe that's fine for this case. Um, it's just another feature that could potentially block consolidation. At the end of the day, it still blocks it less than just putting do not disrupt on the pods would. But yeah, no, your explanation about like having a long enough grace time during disruption to make sure that all of the pods are able to drain off before the termination grace period elapses, that makes sense. Especially for like eventual disruption modes or forceful disruption modes like expiration, drift.
Yeah. Yeah, I guess like where do I go from here on this one then? Like I guess like what I'm proposing is that we solve this within Karpenter, even if eventually we would like to get this into pod disruption budgets. I'm proposing that we solve it within Karpenter first, just to avoid like taking years before we can actually use it. And then if we do need to make any tweaks, we can solve that in a much faster iteration loop. Yeah. I guess what I'm hearing is like it seems like that sounds reasonable, but I guess for the implementation, uh, does anyone have any other thoughts or ideas of how this could be implemented versus maybe what I have here, which would be an additional annotation? Karpenter already has a clock object that gets passed in. It basically just waits for that window. We can bike shed around whether it's an allow window or block window, but that would basically be the approach. Does anyone have any alternative approach that you'd like to see, or any initial feedback that you'd like to see implemented here?
I think that's reasonable. I think like the cron and the clock works. I think one thing I would call is because of the behavior expression, right? Right now with this, it's possible that you're like, oh, I'm running on a node that's gonna expire. In theory, this would stop that, right? Like, I think that's the plan, or am I wrong?
Or this new behavior, it would be, or regardless of whether it's an expiration event or a normal disruption
Right,
event.
right.
So we can walk through two. So one is like, all right, this node is viewed as underutilized.
Right.
At 2 o'clock or 2 a.m. is that example. Disruption is allowed. And so it would process that. It would start disrupting this pod that's on this node because it's 2 a.m. and it's allowed.
Right.
But if it's 6 a.m., it would not be allowed. And it'd be the current behavior of do not disrupt.
Yeah.
If you're at expiration, oh, sorry, did you have?
Sorry, I guess that makes sense to me. I think the only thing is because it changes the default behavior of expiration, deleting pods, we might want like a separate feature flag or something that says like it's okay to breach expiration if you have to not disrupt.
I don't think it does actually.
Yeah,
It doesn't. Okay.
correct.
Okay. That's fine then. I just want that's what something I want to confirm. Yeah, okay, that makes sense.
Yeah. I think right now the issue is, so you have a pod expire or a node expire, you have your termination grace period set, and it has a do not disrupt pod.
Right.
You're basically, unless you do something to manually go and remove that do not disrupt annotation,
Right.
that node is going to live until that termination grace period elapses, and then it's going to delete those nodes or those pods. And
But
there's
that's like
no way to influence the timing other than manually removing the annotation or having some custom controller orchestrate its removal.
got it, makes sense. But I guess how does that solve the issue where your pod's gonna land on a node that's gonna die soon? And the time for you to terminate the pod or the time you want it to live for doesn't match yours.
I
I
I
guess
think
that
that's a
won't
separate
happen.
concern.
Okay. Okay.
Like right, like that's separate, or like pod lifetime is different than do not disrupt, I think. So you
Right,
you
okay,
launch
yeah.
a pod with do not disrupt, but if it happens to be launched within the disruption window, you're accepting that as like, oh, this pod is just disruptible right
Yeah.
now. So like it's a non-issue. Like if you're a user of these new annotations, that would be expected behavior.
Got it. Okay.
How is this different than just modifying your PDB on a cron? Like, even if we're going to implement this logic, wouldn't it make more sense to just have, a cron for your PDB with zero disruptions allowed during certain time periods, um, and just modify that rather than pushing this into the Carpenter level?
Mm, I guess that is totally something that you could do. But it just, yeah, like you said, you then have to manage a different custom controller for it. And I guess what I was thinking is that Karpenter already exposes the do not disrupt as like an available feature. Making that more configurable seemed like a reasonable change. if the long-term goal is to get this change into pod disruption budget, that's something I'd be on board with too. But getting the change into pod disruption budget is going to take a lot longer than figuring that out here. And like Karpenter is literally in a situation where if you're a user of Do Not Disrupt, your pods are at risk of having their PDBs violated. And I think we should fix that.
Yeah, I think I'll definitely have to get caught up with all of the context here, like read this RFC, read the mega issue. I wouldn't want to say anything authoritatively before I did that. Just want to make sure I'm aware of what all of the options are.
Yeah, totally. But yeah, that's why I was wondering if anyone else had any other alternative suggestions. But yeah, please take a look.
All right. With that, we are almost at time. Unless anyone had any last minute thoughts, I think we are good to go. All right. Thanks everyone for joining.
Bye.
Thank you.
Thanks all.